Hey guys, how's it going? In this video we're going to go over two worked examples to show you how to do problems involving thin wedge interference. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get going. Question 1 says an air wedge is formed by two glass slides of length 100mm in contact at one end. The other ends of the slides are separated by a piece of paper 30 micrometers thick, and you can see that in the picture there. Then says light of wavelength 650 nanometers is reflected vertically from the air wedge. Calculate the fringe separation of the interference pattern produced by the air wedge. Well, we want to find delta x here, the fringe separation. We know that the wavelength lambda is 650 nanometers, which is the same as 650 times 10 to the minus 9 meters. We know the length L of the plates is 100 millimeters, which is the same as 100 times 10 to the minus 3 meters. And lastly, we know the thickness of the paper is 30 micrometers, which is the same as 30 times 10 to the minus 6 meters. So writing down our equation for thin wedge interference, we have delta x equals lambda L over 2d. Substituting in the numbers gives 650 times 10 to the minus 9 times 100 times 10 to the minus 3 divided by 2 times 30 times 10 to the minus 6, and if you put that into your calculator you should get an answer of 1.08 times 10 to the minus 3 meters. Lastly, question 2 says an air wedge is formed by two microscope slides in contact at one end and separated by a human hair at the other. Light with a wavelength of 590 nanometers is shone onto the slide and a travelling microscope used to measure the fringe separation. 11 fringes have a separation of 2.20 times 10 to the minus 3 meters. Calculate the width of the hair if the air wedge is 76mm long. Well, writing down what we know from the question here, we're trying to find the thickness d, and we want the distance between two adjacent fringes, not the distance across 11 fringes. So remember, we think about the gaps between the fringes. So if we were to draw out 11 fringes here, then we would have 10 gaps between those 11 fringes. So if we want to find just the distance between two fringes, then we divide this number by 10 instead of by 11, because there's only 10 gaps across all those 11 fringes. So we can say that delta x is equal to 2.20 times 10 to the minus 3 divided by 10, and that gives us 2.20 times 10 to the minus 4 meters. We also have the wavelength lambda as 590 nanometers, which we can write as 590 times 10 to the minus 9 meters. And lastly, the length of the microscope slides is 76 millimeters, which we can rewrite as 76 times 10 to the minus 3 meters. So writing down our equation for thin wedge interference, we have delta x equals lambda L over 2d. Substituting in the numbers gives 2.20 times 10 to the minus 4 equals 590 times 10 to the minus 9 times 76 times 10 to the minus 3 divided by 2d. And if we want d on its own, we can just swap around this term on the left with the symbol d, and that would give us d equals this term on the top divided by 2 times 2.2 times 10 to the minus 4. So if you put all that into your calculator, you should get an answer of d equals 1.02 times 10 to the minus 4 meters. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.